Okay, let's continue with the tutorials. In this section, we will work on developing a controller for an example called Lifting Luggage. I will soon show you what it is. And in the first lesson of this section, we will look at how to unarchive the starter project that has been given to you. And then we will rename this project and then go through this project in this lesson. And in the following lessons, slowly we will build first a centralized controller and then distributed controller for the different mechatronic systems that exist in this lifting luggage example. So let's get started. Go to File, say Unarchive Solution, and select the archive solution that you have received. It's called Lifting Luggage Starter. Now I will leave the default option, which is Documents, NxtStudio Projects, as my destination where this project has to be unarchived. Once the project has been unarchived, it will ask if we want to open that solution. We say yes. It's opening and it's compiling and it's done. The first thing we will do is rename the solution. Before I show you how to rename the solution, let's go to where the file is stored. Now, just make sure that you have not opened this folder inside your Explorer. Why? Because when you do renaming option, and if for some reason any of your programs such as Explorer is inside in this folder, that means then all of these files will get renamed, but the folder itself will not be renamed for obvious reasons that when NxtStudio was trying to rename it, this folder was in use. So this will succeed, but your main folder will remain as Lifting Luggage Starter. So to avoid that, make sure that you have not navigated into this folder. Okay. So right click on the solution and say rename solution and get rid of the word starter. Okay. It will say it has to close so that renaming can be done. Say okay. It will close the solution, rename and open again. Okay, so here is what is inside, and let's close all of them and let's just go through what's inside. You have an app called Lifting Luggage app. Right now it has two instances of function blocks model and control panel. They come from the cat function blocks model and control panel. Let's not worry too much in this section, what these cat models are. We will have a dedicated section for understanding and also implementing cat models in NxtStudio. For now, we just have to know that this is responsible for the physical behavior or the physics behind the model. That means how certain elements have to move and display on the screen, and the control panel has some buttons so that you can control the different mechatronic components. Now, how does the system look like? You can see that here. So it has one mechatronic system, this one, which will go up and down, and there is another mechatronic system here that will go left and right. So the technical words that are used are extending and retracting, and we will use the term lift for this component and we will use the term pusher for this component. And the lift here is a double acting cylinder. What does that mean? It means that it needs two actuations in order to go up and down. That's why you see here two buttons. Lift up is off and lift down is off. That means there are two controls to control the movement of it going up and down. However, the pusher is a single acting cylinder. That means that it has only one actuation that controls whether it is extending or retracting. That means that when this is true, it extends, and when this is false, it retracts, because it is supposed to have a spring inside. So when it is off, the spring will automatically retract it back. Now for the lift, it's a double acting cylinder, and when you say lift up, it starts to go up, and if you just turn it off, it doesn't come back. It will just stop wherever it is. That's the key difference. And if you press down, it will start going down or retracting, and if you midway stop it or turn it off, then it will just stop wherever it is. So that's double acting cylinder, and that is single acting cylinder. Let's go ahead and run this and see how it works. So say start soft PLC. If you don't see this option, then make sure that you have selected local test from this drop down box. So let's do that. I'm going to start a soft PLC, and I'm going to minimize this. Let's go ahead and right click and say deploy, and at the same time run the canvas. Let's start that again. Okay, and we have a workpiece that is here, and let's go through what are the different actuations and sensors. Okay, let's go to the app. Maybe we can watch. It will say, do you want to log in? Yes, and let's watch here. So this is the control panel that is representing this one, and this is the model that representing the rest. Now, as you can see, the model has as an input 3 actuations. That is this one to control going up of this one, and one to control going down of this one, and one to control extending and retracting of this one. Now it has many sensors. One of them is this one. It will tell that lift is retracted. That's why you see the true value. And when this one is true, then that means lift extended will be true. Similarly, we have pusher retracted now, which is true, and then pusher extended. Now there are 2 others concerned with the luggage. This we say are environment sensors. That means they are neither associated with this mechatronic component or this mechatronic component. It comes from the environment. So we have a luggage arrived. That means that whenever there is a workpiece ready to be lifted up, luggage arrived is true. And whenever there is a workpiece ready to be pushed, then luggage lifted will be true. So let's see, operate this manually and see what happens. So the moment I click on lift up button, you should see that lift extend becomes true and lift retracted becomes false, and after some time lift extended becomes true. Let's see that in action. And also you saw that luggage arrived became false and luggage lifted became true. So this became true, this became true, this became true. And NxtStudio makes it easier to show which values changed. Similarly, now you can turn that off. Now note that if you try to do both the operation at the same time, it doesn't know what to do because both of them are true. So try to avoid doing that. It's a simulation, it's okay, but not good for a real machine. So let's turn that off. And let's turn on the pusher. When you say push, it will push. And when you say turn it off, it will go back. That's the difference between the double acting cylinder and a single acting cylinder. Okay, so we saw all the different values and how it's supposed to work. Now let's build an automatic control. This is a manual control, right, using buttons. So the goal of this section is to learn how to build a automatic control for this example. We will stop here for this lesson. You got a brief introduction of what the example is. And in the next lesson, we will go ahead and create our basic function block that will control this whole system. Let's do that.